Hello and welcome. Thank you all for being here. I appreciate it. To start things off with, as with everything in life, there is fine print. So there's terms and conditions, there's a bunch of legal text. If you're curious, my best idea, take a picture, ask ChatGPT to summarize it for you, and we're all good. I am James. Thank you all for being here. I am a product manager at Databricks. It's nice to be back at a Spark event. The last Spark event I was at was Spark Summit in 2017. So it's really nice to be back. I joined Databricks specifically to get closer and back into the Spark ecosystem. Today I'm going to be running through something that came out actually in Spark 3.5, but seemingly not enough people know about. And it's something that I'm pretty passionate about because I think it's very interesting, and that is Spark Connect. As a disclaimer, I am just a mouthpiece here. The Spark community did all of the work, and a lot of credit goes to the very diverse and hardworking Spark community. I am just the messenger here, but I want to deliver a message around something that I think could be really impactful to you. So we're going to do a few things today. We're going to look at traditional Spark clusters. This is the what led to Spark Connect in the first place. Why did we start thinking about this problem? 2, we'll dig into under the covers a little bit. What is Spark Connect? How does it work? What use cases might it be good for? And then 3, it's really the what's in it for me. It's making it real and trying to tie in real life use cases, how you might use Spark Connect in use cases that you already have. Or if you don't have any, thinking about Spark Connect for use cases that you might have in the future. So here's the TLDR. This is if you take nothing away from this presentation except this. And I like to do this just so you sort of know, like, what's the end message that I want to leave with you. Spark Connect is an abstraction layer, so you can spend less time thinking about and managing, troubleshooting, debugging Spark clusters. That's it. Spark Connect abstraction layer takes away a lot of the pain of Spark clusters. And if that's all you want from this session, you can definitely save some time. I'm going to go into the specifics, but that's the high-level message that I'm going to try and leave you with today. You're going to hear me talking a lot about Spark. And just to disambiguate a little bit, because that could be, we're at a Databricks conference, so that could be a confusing term. I'm referring in this presentation mostly to open source Apache Spark. When I'm referring to something specific to Databricks, I will do my best to call that out. But if I'm saying Spark, just know that I'm referring to open source Spark. So this is a really important call out because this is not tied to Databricks. This is something that exists in Spark today, which is why I want everybody to know about it. So if you've used Spark for long enough, this will make intuitive sense to you. This is kind of a high-level overview of a traditional Spark cluster. You have tens, hundreds, thousands of applications. You have a monolithic Spark driver, and then you have n number of nodes. Could be small, single-digit number of nodes to thousands of nodes. Back when I ran a Spark service at Google, we had a leaderboard for who was creating Spark clusters with the greatest number of nodes. So I've seen, and I think many of you have probably seen Spark clusters that range wildly in their size. Because it can be really hard to balance one giant Spark cluster, what often ends up happening is people will create many different Spark clusters. Sometimes this is around security isolation. You want a Spark cluster for a given team. Or it's around performance. You want a Spark cluster specifically for a really annoying job that may be poorly written. Or you want a Spark cluster with certain accelerators like GPUs. Maybe you're using different clouds or different regions. You have Spark clusters in different regions. The end result is you have a complicated technical architecture. I love Spark, but like the architecture is complicated. You have a complicated technical architecture that's usually in most large customers repeated kind of all over the place. So you have a headache that's been copy and pasted kind of throughout. Let's dig into the headache a little bit. The Spark driver is monolithic, and there's a lot that's packed into it. And this is sort of the seed for the initial seed for why Spark connects. So you have application logic, you have an analyzer, you have optimizer, scheduler, you have the distributed execution engine. You have a lot of complexity packed into this single layer. And this complexity makes managing Spark clusters potentially really hard and annoying. And there's really there's not great isolation or abstraction in this monolithic Spark driver, which can create quite a bit of pain. Now, what's interesting is because Spark can be complex and difficult to run, people often run Spark in data centers. You may use Databricks, you may use Spark on EMR, you may use Google Cloud Data Proc, you may run Spark on Kubernetes yourself. But the end result is people often run Spark in data centers where they have the capacity, they have infrastructure, they have the wherewithal to run this really kind of complex package in a distributed and well-run way. Problem is people are using and building a lot of data-driven applications that don't live in a data center. You may have an IDE that you like using for development. That's probably living on your laptop, not in a data center. So the question becomes, how does that actually interact with the Spark cluster? You may have application servers or web servers that want to use or rely on Spark. They may not be in the same data center or a data center at all. You may have other programming languages. You may want to write Spark jobs in Go, for instance, and that's just a bit of foreshadowing. You have edge devices. So you may be running a manufacturing plant and you have machines that are emitting telemetry that you need to aggregate and process. Or you're working with Raspberry Pis. Raspberry Pis are embedded all over the place. It's really surprising what they're actually in. So you may have all of these edge devices all over the place. And again, they're far away from where you're actually running Spark. So a question becomes, how can you bring them closer together and also solve the pain of managing complex Spark clusters? Well, people have tried to kind of embed, so to speak, Spark in applications. One approach, people use SQL. SQL's pretty straightforward, right? The problem is using SQL as just your only abstraction mechanism is cleaner. You can kind of deal with text and strings, but it's not as expressive as all of Spark would allow for. So by only pinning to SQL, you're kind of self-limiting how much of Spark you can actually use. There's been a preponderance of different kind of proxies for notebooks and IDEs. So I just actually had lunch with a customer, and we were reminiscing on like Livy, but there's proxies for notebooks. There's SSH tunnels that people have built. Cloud providers all have their own tunnels. So people have tried to solve connecting and actually using these Spark clusters closer to the data applications through a host of different mechanisms. If you want to use a language that doesn't have JVM interoperability, you're in a much worse spot. It's either really difficult or almost impossible. So in some cases, people have to even get out of the programming language they're comfortable with to go use Spark. Multi-tenancy can cause a host of really annoying problems. And I'm like slowly surveying the audience, and I'm seeing pain in people's eyes as I show these. So you have maybe an application that's really noisy and it causes a lot of out-of-memories issues on your cluster. You may have dependency problems. So maybe somebody's written a Spark job and the number of dependencies for that job or the dependencies that job requires is huge. Upgrading Spark clusters is also traditionally for a lot of people a pain. If you are, for instance, using Spark 3.1, somewhat recent version of Spark, and you want to go to like Spark 3.5 or Spark 4, it's often quite logistically complex for people to go upgrade their clusters because they have to upgrade the cluster and also all of the applications that talk to it kind of in one full swing. And that can be logistically very, very difficult. Debuggability. It can be really hard to understand why something in a Spark cluster is not working because everything's all kind of muddled together. So people go and look at tailed Spark logs, try and figure out what's going on. You may have 1,000 nodes and you are looking for the problematic job by looking at memory on nodes, and you're trying to find out what job is running on that node. It can be really complex to debug what's running on a multi-tenant Spark cluster. And that also dovetails to observability. Just understanding who's doing what they're using can also be logistically pretty difficult. You don't have to raise your hand. This is more a rhetorical question. But I would ask another way of looking at this. Yeah, one person raised their hand. I will see if I can get you a t-shirt. Says, I love managing Spark clusters. But most people generally don't like managing Spark clusters because it's not a value add for what most people want to do. They're managing infrastructure when in reality, they want the outputs from that infrastructure. So has a solution been proposed to this? Well, if you look at hyperscaler solutions, I would argue that one of the kind of canonical Band-Aid solutions is let's just make it serverless. Like serverless fixes everything, right? Well, we'll hide the compute, and if you don't see the problem doesn't really exist, right? Serverless is just a Band-Aid because all you're doing is abstracting away the compute. You're not solving the underlying problems in the actual like Spark execution engine and Spark itself. You're just trying to Band-Aid the infrastructure and veneer away all of the problems. So serverless has traditionally been pitched as a solution to these problems, but in just itself, it is not a solution to the problem. Well, what is a solution to the problem? Spark Connect. How did Spark Connect come about? Spark Connect, as with many improvements in the Spark project, came about through a Spark improvement proposal. If you're not familiar with how this works, I would actually encourage you to go get involved in the open source project. The Spark people are awesome. But also, a lot of really big upcoming features in Spark have improvement proposals. So you can actually see what's coming in Spark 4.1 and beyond by looking through these improvement proposals. So it's really cool. You can actually get a really good sense of where the Spark project is headed. In this case, Spark Connect was proposed in Spark 3.4. It was released in Spark 3.5. So what is Spark Connect? The goal with Spark Connect is to decouple the architecture. We want to essentially create a client-server architecture in Spark where you can use a thin client API to interact with Spark. So instead of trying to interact with Spark directly, you're actually interacting with Spark Connect. And I'll dig into how this works in a little bit more detail, but you can think of Spark Connect as really just an abstraction mechanism that allows thin client and not fat client APIs or SDKs to connect to Spark clusters. So how does Spark Connect work in detail? And I'm going to step through each one of these. So there's a lot of text on these slides, but I'm going to go through all of this kind of in pieces. So under the hood, what Spark Connect is doing is the clients are sending unresolved query plans to Spark. This is all done over HTTP2 gRPC. The code runs on a Spark server, and the results are streamed back in Arrow and gRPC. So essentially, client comes up with an unresolved query plan, hands it off to the Spark server processes the data, returns results. And this is the, at its highest, most purest level, the abstraction mechanism of Spark Connect. So it starts with the declarative API. In this case, it's showing Python, the declarative API. You're writing out what you essentially want Spark to do. All of that is done through data frames. In Scala, it's done data sets and data frames. That job is translated to an unresolved query plan. And I will say this unresolved query plan is also language agnostic. And this will become really important in a minute. But this unresolved query plan is essentially a blank template, which is how Spark Connect can go implement support in other languages, which I'll touch on in a minute. This logical plan is taken by the Spark server and run as a Spark job. So it essentially takes the language agnostic input that the thin client sent the Spark server, it runs, and then it streams the results back to the client. So in this case, you don't have a client that's interacting with the Spark server directly. The client locally on the machine is coming up with the unresolved query plan and just handing that off to the Spark server. And then the Spark server takes that and runs it. So there's no SSHing involved. There's no crazy proxies. It's all a very clean abstraction mechanism. Spark Connect has had a lot of work go into it. It was introduced in Spark 3.5. Spark 4 expanded support for Scala, so essentially there's parity between Scala and Python now. But there are a few sharp edges. I would love to sell, I'm a product manager, I love to sell unicorns and rainbows, but I will be realistic. There are a few sharp edges. The biggest of which is Spark Connect does not support RDDs. There was an architectural decision made that Spark Connect would support data frames and newer versions or kind of newer paradigms of programming in Spark, which meant that RDDs are essentially too low level for Spark Connect to support. That's something that's probably unlikely to change in the future with Spark Connect. You also don't get a Spark context. Right now, Spark ML does not work, although that is one point that I suspect will change over time. So the biggest lever for you to decide whether Spark Connect makes sense for use cases, are you programming in RDDs? If you are dead set on programming in RDDs, or you have libraries that do, Spark Connect, at least right now, will not work. If that is not a constraint for you, Spark Connect would, I'm very confident, work for your use case. This takes us closer to kind of the perfect compute where everything is isolated. You have the Spark Connect interface API, and then you have the client libraries that talk to the Spark Connect API. Spark Connect hands off the plans to the Spark driver, and then your job gets run on Spark executors. We start isolating things and componentizing things with the isolation of Spark Connect. This becomes really important for reasons I'll go into in a minute, but we're trying to essentially break things up and modularize them. So let's go back to the use cases where you have a bunch of stuff that you may want to use Spark with. You may want to embed Spark in a notebook or a web UI. What does that look like with Spark Connect? I'm going to take a quick note and just say Spark Connect is GA in Spark 4. There's a ton of stuff. Spark releases occur, I looked like about every year. There's a ton of stuff in Spark 4. Spark Connect is but one piece. There's, for instance, a ton of SQL improvements in Spark 4. If you're interested in changes in Spark 4, there's a session. If you're interested in upcoming changes in Spark 4.1, there's also a session as well. Those sessions are being led by 2 PMC members from the Spark team. So I will just shout out, say if you are interested in what's new in Spark 4, what's coming in Spark 4.1, there's sessions that dive into a lot of the small pieces in here. I'm just focusing on one kind of small part of Spark 4. So Spark Connect is GA'd in Spark 4. Do you need to care? Do you need to know? Well, not really. If you're not using RDDs, your job would probably work with Spark Connect today out of the box. And you actually may be using Spark Connect. I suspect some of you are actually using Spark Connect and you don't realize it. And I'll unpack that in a minute. But more likely than not, your code would work or your job would work on Spark Connect today. What do you get? Well, you get dependency isolation. You have that abstraction layer, so you no longer have to think about dependency management, memory management. A lot of those problems of traditional Spark clusters go away. It also means, and I'll show some examples here, some code examples, and I have a link later on in the presentation to a GitHub repo for people who want to go and play with some of the examples. But this also makes upgrading Spark clusters super easy. And what do I mean by super easy? It's one environment variable change. If you want a job to point to cluster A one day, and then you want to point it to cluster B another, you just change one configuration variable. It's changing a URI prefix. So if you want to go upgrade, you just point your job at a new thing, and it works. You don't have to think too hard about it. Spark API, Spark Connect has backwards compatibility built into it. So if you point a job to an upgraded Spark cluster, you don't have to think twice about it. It just works. And what don't you get? Well, mainly the RDD APIs. If those are a deal breaker, Spark Connect would not work for you. If you want to go tune like JVM properties, for instance, that would also not work as well. What if you're a data engineer and you want to use Spark Connect? So what does it sort of give you? Well, you can use Spark from pretty much anywhere. You could open up a client SDK, for example, in an IDE, and go connect to a Spark service without a lot of configuration on a laptop or a web server or a front-end application. Because you can do that, you can also do things like step debugging inside of your IDE. So if you are writing, for example, a PySpark job, and you want to go do breakpoint debugging, Spark Connect makes that possible locally because it's creating the query plan and the IDE are working together. So you're actually able to do like breakpoint debugging and step through Spark jobs locally on your computer using a remote Spark resource. You could use a local Spark resource too, but using really any Spark server. Spark Connect supports non-JVM languages. I have an example of this. And it makes upgrading Spark just dead simple, or changing between a staging and a prod environment, which I will show you. There's one Spark property that you have to change, so super simple to actually enable using Spark Connect. If you want to go use the PySpark Spark Connect client, it's just one Python library. So again, what we're trying to do with Spark Connect, but also I think Spark in general is trying to just make things much easier to install and use out of the box. That's just a brush, though. Like, what's really, if I were you, I would say, what's really in it for me? So let's go back to the kind of operational issues that most people have with Spark clusters. You don't have to worry about out-of-memory issues because the Spark Connect gateway is isolating jobs and componentizing jobs. You don't have to worry about dependency conflicts. Upgradability, as I'll show you, is not a problem. Observability and debugging are much, much simpler. So it's trying Spark Connect really abstracts away a lot of the traditional problems people have in wrangling Spark clusters away from you, so you can actually focus on writing your code. Specifically, what does this mean? Well, since a lot of things are running locally in the client, you aren't going to go kill the Spark driver with out-of-memory issues. Dependencies are isolated for each application running with Spark Connect, so you don't enter this really complex like dependency heck where you're trying to wrangle dependencies between jobs out. Upgrades can occur independently of applications. So you can upgrade a cluster, you can create a new cluster and just point your apps at it, and you can decouple the two. So cluster upgrades are much, much easier, which allows you to get newer Spark features faster. You can apply security upgrades. You could change, maybe you want to go from a VM to a Kubernetes-based Spark environment, whatever. It's much, much easier. Step-through debugging allows you much easier control over debugging your Spark applications. And because of that observability, there's better logging and metrics. And I will say on the last point, the observability piece is also very, I think, top of mind for the Spark project as well, just kind of following some of the discussions in the Spark project. I think that's an area where there will be some expanded focus in the future. With Spark Connect, you get client isolation. So this slide was actually taken from a Databricks talk on LakeGuard, which is kind of better security isolation for Spark clusters. Spark Connect is one component of that. But because you have that Spark Connect layer, and each client's talking to Spark Connect individually, you do get isolation from the Spark engine. So there's a client-server architecture. And you also get isolation from other users. So you don't have users tromping on each other as much. Now, once they enter the actual Spark execution environment, things can become a bit more difficult, but at least starts to abstract away some of the kind of shared infrastructure that can make managing and securing Spark clusters really, really annoying. I'll walk through examples of each of these, but at a high level, Spark Connect is in Spark 3.5. It's GA in Spark 4, so you could go use it today. There's SDKs that are evolving with new language support for Spark Connect, and you can build interactive data applications. So kind of like, what does this look like? Some people don't like using a web notebook or IDE. I'm at a Databricks conference, so I have to be careful. But I don't like using a web notebook. I just don't. I never have, and I probably never will. I like using an IDE. That's just me. With Spark Connect, it's super simple to use your IDE of choice and go run your Spark jobs. So in this example, there's some code that will get converted into an unresolved logical plan, passed off to the Spark server, and then the results streamed back. In this case, if you wanted to use Python, all you have to do is install one Python package, and you're good to go. I had mentioned that some of you may have used Spark Connect without knowing it. If you've ever used the VS Code extension for Databricks, or you've used Databricks Connect, that's using Spark Connect. So if you've ever touched either one of those, congratulations, you're already using it. Now you know how it works. But the neat thing is that technology exists in Spark fundamentally. So it's not Databricks specific. That mechanism to actually connect an IDE to a Spark cluster is part of Spark, which is kind of the key thing that I'm trying to impart. Here's an example which I saw somewhat recently that kind of blew my mind. There's Swift, there's Go, there's Rust, there's .NET clients for Spark. I will give a disclaimer. These are developing. A lot of these are actually much more feature complete in Spark 4, but you're starting to see new language SDK implementations for Spark Connect. So if you really love using Swift and you want to go use Swift in Spark, and credit to the team at Apple for building, I think, all of this, you could do that today. Which I think makes Spark long-term much more adaptable because programming languages, some come, some go, people's preferences kind of vary. This makes Spark much more accessible, in my view, to a much wider range of people because different languages, you can kind of meet people where they are. You could also have interactive applications. So if you wanted to go build a dashboard, you could go do that. If you wanted to go build a Python application where you have a You're just doing data serving, you want to go process data on the back end with Spark cluster, yep, you can do that. So you can basically, because Spark Connect is client-server architecture, you can embed a Spark cluster in your applications pretty trivially at this point. Because all that is happening is, in this case, let's say it's Python, that Python library is just creating that kind of abstract, unresolved plan, and that's been sent off to the Spark server. So you don't have to think too hard about how all of it gets executed. Say you want to go switch Spark clusters. I've alluded to this a few times, but say you have a dev, test, and prod Spark server, and you want to go run a job on a staging environment and then switch it over to prod. Literally, all you have to do is change one variable, and that variable is just a URI for what Spark cluster you're talking to. Spark Connect, the abstraction layer, makes it very easy to point that job at any number of different environments, or you could run that job concurrently on all different, multiple environments all at once. In this case, we've mocked up like the URIs, but it's very easy to change what Spark Connect is talking to. And again, Spark Connect is designed to be backwards compatible. So if you went and upgraded to a new Spark version, the job that's using a Spark -1, -2 version should work. A lot of thought went into designing Spark Connect to make upgradability seamless without you having to worry about, will this work, will this break, how do I actually upgrade my cluster? This example is loosely one from the Spark documentation, but it kind of shows in detail, like what if you wanted, like looking at, okay, it's counting A and B lines. So say you had a log file and you just wanted to count A and B lines, and you had a Spark server running locally. And this would, the URI is kind of bogus, but like, you get the point. It would talk to Spark locally, but if you wanted to go run it remotely, you just change the connection URI, and it just works out of the box. Say you had a Databricks classic cluster running, and you change this to go point to a Databricks cluster. It would basically create that abstract plan, ship it off, and then stream the results back to your laptop. So all you need to do is literally just run your Python interpreter and pass it your Spark job, and it runs out of the box. So you're not thinking about like SSH tunnels. You're not thinking about trying to use Spark submit. You're not thinking about how to submit this to a Spark cluster without overloading it. It's designed to work seamlessly out of the box. There are a few questions that I often encounter. RDDs is the big one, which is why I've tried to be really explicit about it. But one of the questions is there an auth mechanism built into Spark Connect? This is a euphemistically said, choose your own adventure answer. It could be a good answer, it could be a bad answer, and I will take no claim on which one it is. There's not an auth mechanism built into Spark Connect because coupling, I think there's a fair claim that coupling auth and Spark could also be like kind of annoying and weird, but it's using HTTP 2, so whatever proxy or network that you've set up, it just kind of transparently works. So as long as you've set up a networking pathway between the client and the server, things work, but there's not an auth mechanism built directly into Spark Connect, because arguably that could also get really messy and kind of annoying to support long term. Is this a feature that's specific to Databricks or X versions of Spark? Nope. It was placed in Spark 3.5, which means it's just sitting there for any environment that's running Spark 3.5. I don't know anybody that's deployed Spark 4 images yet. It's coming to Databricks relatively soon. But it's built into Spark. So if you have a Spark environment, Spark Connect works. I strongly suspect that Spark Connect will also be used by non-Spark engines. And what do I mean by this? If you want to talk Spark APIs, Spark Connect, again, it's kind of a thin client that takes Spark APIs and converts it into an unresolved plan. So I expect other engines that want Spark interoperability will probably themselves use Spark Connect, because it essentially allows you to convert from a set of Spark APIs to an unresolved plan that can get run either in a Spark engine or whatever proprietary query engine you have. So I fully expect in the long term, Spark Connect will also be adopted, the Spark Connect APIs will be adopted by non-Spark runtimes, because it creates a bridge for non-Spark runtimes and Spark runtimes to run the same Spark code kind of transparently behind the scenes. It's a hypothesis. I hope it comes true. Will it do everything? No. As I've covered, it's only in Spark 3.5 and above. It's GA'd officially in Spark 4. If you, it's not, Spark Connect is not intended to be the only way that you do things, and it would be foolish of me to suggest. But it could potentially be very useful for a lot of use cases, which is why I wanted to give a talk to sort of advocate for its availability, because it really can be quite powerful. If you're interested, this is a good slide to take a picture of. The QR code is not nefarious, I promise. I'm not going to rickroll you. That's a link to a GitHub repo with a bunch of examples. If you're curious about this, I would encourage you to take a look. There's a lot of examples that have been placed inside of the Spark project. A lot of Bricksters have created repositories with Spark Connect examples. Some of the Bricksters even created the SDKs, or the client implementations for some of the programming languages. Like I think a Brickster created the Go implementation. So there's a lot of activity around Spark Connect, so I'd encourage you to take a look. Finally, Spark is open source. If you are curious, if you have an opinion, if you have a complaint, if you are curious, get involved. Part of why open source software is so powerful and so enduring is not only because it presents an abstraction layer so people feel like they have a lot of freedom of choice, but also the diversity of thought is part of why open source, I think, is so powerful. So please, I strongly advocate, if you're on the fence, just get involved. I don't think you'd regret it, and everybody's really, really friendly. More mandatory slideware for you. If you're curious about continuing your journey, there's several options available to you. The feedback on the surveys is really useful, so please, I implore you, fill out the surveys. Good, bad, whatever, they're very, very useful. And with that, I think we have 5-ish minutes, so I'm happy to take any questions that anybody has. Thanks.